Yes, the incorporation of a phase control unit for a three-phase environmental control unit is standard practice in the commercial sector. Phase controller is a method of controlling the alternating current, or AC, power delivered to a load by varying the firing angle of silicon-controlled rectifiers, or SCRs, or other switching devices such as triacs in the AC circuit. This technique allows for efficient control of the average voltage or current supplied to the load, which in this case is the three-phase environmental control unit. Firstly, understanding the basics of phase control involves the use of semiconductor devices like SCR or triacs as switches. These devices can be turned on at a specific point in the AC cycle, thereby controlling the amount of power delivered to the load. The point at which the device is turned on is referred to as the firing angle, usually denoted as alpha. By varying this firing angle, the average voltage and current supplied to the load can be precisely controlled. Secondly, in the context of a three-phase system, the phase control unit typically consists of 6 SCR or triacs, 2 for each phase. These devices are arranged in a configuration that allows for independent control of each phase. The firing angle for each phase can be adjusted to achieve the desired output voltage or current. This independent control allows for balanced operation of the three-phase load, even under imbalanced conditions. Thirdly, the advantages of using phase control in environmental control units are numerous. One of the primary advantages is energy efficiency. By reducing the voltage supplied to the motor, the power consumption of the motor can be reduced. This is particularly important in applications where the load varies over time, such as in heating, ventilation, and air conditioning systems, or HVAC systems. Phase control allows the system to adjust the power supplied to the motor based on the actual load requirements, thereby minimizing energy waste. Fourthly, another advantage of phase control is improved system performance. By controlling the voltage supplied to the motor, the speed and torque of the motor can be precisely controlled. This allows for precise control of the environmental conditions, such as temperature and humidity. In addition, phase control can help to reduce stress on the motor, extending its lifespan. Fifthly, the implementation of phase control in three-phase environmental control units typically involves the use of a sophisticated control system. This control system monitors the load requirements and adjusts the firing angle of the SCR or triacs accordingly. The control system may also incorporate feedback mechanisms to ensure that the desired environmental conditions are maintained. For example, a temperature sensor may be used to provide feedback to the control system, which then adjusts the firing angle to maintain the desired temperature. Sixthly, in commercial buildings, environmental control units are often used to maintain comfortable temperatures and humidity levels. These units typically consist of a compressor, condenser, evaporator, and expansion valve. The compressor is responsible for circulating the refrigerant through the system. The condenser is responsible for rejecting heat from the refrigerant. The evaporator is responsible for absorbing heat from the air. The expansion valve is responsible for reducing the pressure of the refrigerant. Seventhly, the use of phase control in these systems can significantly reduce energy consumption. For example, in a variable air volume, or VAV, system, the amount of air supplied to each zone is varied based on the occupancy and activity levels in that zone. Phase control can be used to adjust the speed of the supply fan motor, thereby reducing energy consumption when the demand for air is low. Eighthly, furthermore, phase control can also improve the power factor of the system. Power factor is a measure of how efficiently electrical power is used. A low power factor indicates that a significant portion of the electrical power is being wasted. Phase control can help to improve the power factor by reducing the reactive power drawn from the electrical grid. Ninthly, considering the National Electrical Code, or NEC, relevant articles should be consulted for proper installation and safety requirements. While the NEC doesn't specifically mandate phase control, it provides guidelines for motor control circuits and equipment. For example, NEC Article 430 covers motors, motor circuits, and controllers, ensuring that the installation is done safely and according to code. Tenthly, some of the challenges associated with phase control include harmonic distortion and electromagnetic interference. Harmonic distortion refers to the presence of unwanted frequencies in the AC waveform. These frequencies can interfere with other electrical equipment. Electromagnetic interference, or EMI, refers to the emission of electromagnetic energy that can disrupt the operation of other electronic devices. These challenges can be mitigated by using appropriate filtering techniques and shielding. 11thly, in addition to the technical considerations, there are also economic considerations to consider. The cost of implementing phase control must be weighed against the potential energy savings. In many cases, the energy savings will offset the cost of implementation over time. Furthermore, government incentives and rebates may be available to help offset the cost of implementing energy-efficient technologies. 12thly, the long-term reliability of the phase control unit is another important consideration. The components used in the phase control unit should be selected for their reliability and durability. Regular maintenance should be performed to ensure that the unit is operating properly. This may include checking the firing angle of the SCR or TRIACs, inspecting the cooling system, and replacing any worn or damaged components. 13thly, phase control units are typically installed in a dedicated electrical panel. The panel should be properly grounded and protected from overcurrent. The wiring should be sized appropriately for the load. All electrical connections should be made securely. 14thly, the selection of the appropriate phase control unit depends on the specific application. Factors to consider include the voltage and current requirements of the motor, the desired level of control, and the environmental conditions. It is important to consult with a qualified electrical engineer to ensure that the appropriate unit is selected. 15thly, the use of phase control and three-phase environmental control units is a well-established practice in the commercial sector. It offers numerous advantages, including energy efficiency, improved system performance, and reduced stress on the motor. While there are some challenges associated with phase control, these challenges can be mitigated by using appropriate design techniques and best practices. By carefully considering the technical and economic factors, it is possible to implement phase control in a cost-effective and reliable manner. 16thly, to further elaborate on the benefits, phase control allows for soft starting of motors. When a motor starts, it typically draws a large amount of current, known as inrush current. This inrush current can cause voltage dips and can stress the electrical system. Phase control can be used to gradually increase the voltage supply to the motor, thereby reducing the inrush current. This can help to protect the electrical system and extend the lifespan of the motor. 17thly, beyond the energy efficiency and motor protection aspects, phase control can also contribute to reducing audible noise from environmental control systems. By precisely managing the motor speed, the system can operate more quietly, an important factor in environments where noise levels are a concern. 18thly, phase control systems can be integrated with building management systems, or BMS, allowing for centralized monitoring and control of environmental control units. This integration provides valuable data on system performance and energy consumption, facilitating proactive maintenance and optimization. The BMS can also adjust the phase control settings based on occupancy schedules and other factors, further enhancing energy efficiency. 19thly, the use of advanced control algorithms can further improve the performance of phase control systems. For example, adaptive control algorithms can learn the characteristics of the load and adjust the firing angle of the SCR or TRIACs accordingly. This can result in more precise control and improved energy efficiency. 20thly, in addition to SCR and TRIACs, other types of semiconductor devices can be used in phase control systems such as insulated gate bipolar transistors, or IGBTs. IGBTs offer several advantages over SCR and TRIACs, including faster switching speeds and lower losses. However, IGBTs are typically more expensive than SCR and TRIACs. 21st, when designing a phase control system, it is important to consider the thermal management of the semiconductor devices. SCRs, TRIACs, and IGBTs generate heat when they are switching. If the heat is not properly dissipated, the devices can overheat and fail. Heat sinks and cooling fans are often used to dissipate the heat. 22nd, the wiring and connections in a phase control system must be carefully designed to minimize voltage drops and ensure reliable operation. The wires should be sized appropriately for the current they will be carrying. The connections should be tight and corrosion resistant. 23rd, in summary, the adoption of phase control units and three-phase environmental control systems within the commercial sector is a standard and beneficial practice. The ability to modulate power delivery precisely translates to energy savings, improved system longevity, and enhanced environmental control. While proper design, installation, and maintenance are critical to ensure optimal performance and safety, the advantages of phase control make it a valuable component in modern commercial HVAC systems. Its integration with building management systems and the potential for advanced control algorithms further solidify its importance in optimizing energy consumption and maintaining comfortable and efficient environments.